Hey guys and girls, in 7th grade math, I thought I might take some time to walk you through our new assignment, coding shapes. So let me show you first how to do your blueprint, coding shapes, and this is the blueprint. So you're going to put the name of your polygon, which might be a triangle. Okay, you're going to put that on your coding paper somewhere in that area. And then I told you to come down with my line's not very straight because I don't have any lines to go by, but dot you a line where 0 degrees would be. And remember that that is the straight. This is very hard to do, but straight line. I'm not going to write very much, obviously. Alright, that means straight. And then you'll come up here and put you a line. That would be your start line. And then for every box on your grid is equal to 1 foot. So if I did 4 boxes on that one side of my triangle, then that would be 4 feet out in the hallway when you're actually programming your robot. Okay, on this next line, on the computer, I gave you, on the example on Canvas, I gave you a formula that said S equals n minus 2 times 180. Okay, and what you would do for a triangle, the n would tell you how many sides your shape has. A triangle, of course, has 3. 3 minus 2 is 1, and 1 times 180 is 180, of course. And then that would tell me the total measure of all the angles inside the triangle. So I'm going to just go ahead and draw my triangle right here quickly. There we go. And so this angle plus this angle plus this angle equals 180. Now if I want to know what each angle is, I would divide by the number of angles, which would be 3, and of course I would get 60 degrees. So when I go to code, I'm going to tell the first roll. So let me go on over here to my code program, which is edu.sphero.com. I'm going to go to programs, create, and I'm going to call this coding shapes, and then the name of mine would be triangle for this example anyhow, and then create, and then it opens up. And then on my first roll, and remember if you guys remember, we modeled this for a square. My first roll is going to be 0 degrees, or straight ahead. And then I've got to put in some type of speed, and I'm just going to put 10 and 5 seconds. But I do know that that roll has to be for 4 feet, because that's how long I made my side right here. If that was 4 boxes on the grid paper, the graph paper, then on the real life, when I actually run the robot in the hallway, I need it to go from the start point 4 feet, and then I need it to stop, turn, go here 4 feet, stop, and turn here, go 4 feet back to this starting point. Okay, so on my first roll, like we said, it's going to be 0 degrees or straight. And then on the next roll, if we'll look back here, I need it to go at this angle, from the 0 degree line. And I'm not going to go this direction, this smaller angle in here. I need this bigger angle here. So if you look at this, it needed to be somewhere in that direction. So how do I know what that angle is? I know that this angle here is 60, and I know that a straight angle or a straight line is 180 degrees. So I take 60 from 180, and that should, if my math is correct, be 120. Alright, and then I want it to travel the same speed and the same time. That way my side lengths are the same. And then I'm going to roll again, and I got to go back and look and see what that angle is. So I want to go at this direction. Okay, so if I have a line here, I need to know what this angle is. Alright, and so if I know that this is 60 degrees, it's going to be 180 plus 60, which should be 240. So I'm going to go 180 and then add 60 more. Okay, and then I still got to put in the same speed, still got to put in the same time. Okay, and then this should get a triangle. Okay, it's going to get me a triangle, but here's what I have to debug, and this is the part that I have to fix. I have to get this first roll to roll exactly 4 feet. So I have to adjust my speed and my time for that to roll exactly 4 feet on this roll right here. If I get that to roll 4 feet, then it should roll 4 and 4 once I have all of my rolls at the same speed and the same time. So you guys can look at this for other shapes too. So if I have, let me change back to black. So if I have a straight line here, okay, and that was my 0 degrees, then I will get, let's just say I do a pentagon. Okay, that would be 5 sides. I have to do my math here for 5. So that would be 3 minus 2, or 5 minus 2 is 3. 3 times 1 is 80. So that'd be 300. 3 times 8 is 24. Is that 5? Trying to go too fast here. 180 times 3. 180 times 3 is 540. Okay, that's what I get for doubting myself. And then 540 divided by 3. 540 divided by 3 is 1. 540 divided by 5. Let me slow down. Is 108. All right, so this first angle here is going to be 108, and then 108, and then 108, and then 108. And I know that's not. I'm just trying to give you an example here. So my first one would be 108, and so then I would do my roll for that one at 0, and then I do my next roll at 108. Okay, but that doesn't. 108 is not pointing in the right direction. It's actually pointing down this way. So what I got to remember is I don't want this angle. I want this angle. All right, so that would be 108. or 180 minus 108, and that should be a 72-degree angle. So then if I change this to 72, that looks like the angle that I have here. And then I will just keep noticing what angle that I actually have until I come back to my start point. Okay, guys, I hope that helps. And then, of course, this is on Canvas, so you can watch it as many times as you need to. And hopefully this helps you get your blueprint and your steps and your coding done. And then after we get all that turned in, then we're going to start letting you guys try it in the hallway and debug until you can get your programs to actually travel the correct distances. Alright, I hope this helps. This is a little challenging project, but I know you guys can do it.